Hello everyone, myself Vijay Kumar Verma. I am faculty of Department of Computer Science and Engineering, Institute of Engineering and Technology, Bundelkhand University, Jhansi. And today we are going to discuss about sorting techniques in data structure by using C. So, let us start. So, as we know that array is very important topic from various application point of views, where we had seen the definition of array as it is a collection of homogeneous data types data elements like marks of students, like roll number, like name, etc. Which simply means that array is always used to collect the elements which are having of same data type. Okay. So, under that array we have its another important application which is called or known as sorting technique. So, sorting have another importance in data structure, and we have so many sorting techniques in data structure like bubble sort, selection sort, insertion sort, merge sort, quick sort, and other than this we have radix sort, bucket sort, heap sort, and other some more applications also. So, where we will discuss each and every algorithm one by one. So, let us start with bubble sort. So, when we talk about the bubble sort, its concept says that like a bubble in the water, it automatically comes up from the bottom to the upper layer. Same like that, when we will apply the bubble sort among the different elements of the given array, the largest or the smallest element of the array automatically moves to its proper position. Okay. So, let us have an example for the bubble sort. So, we have an array of 5 elements, suppose some array of 5 which are having the elements like 15, 7, 4, 11 and 2, where we know it have 0th index, the 1 index, number 2, 3 and 4. So, the concept of bubble sort says that we will choose first 2 adjacent elements of the array and compare them with each other. So, let us have first 2 elements. So, those first 2 elements are some array of 0 and array of 1. So, as bubble sort says, so it's let us have comparison array of 0. So, if array of 0 is greater than array of 1, then we will perform a swap operation and array of 1 element will move to array of 0th position and array of 0th position element will move to array of 1 position. So, here as we can see that array of 0 is having 15 and array of 1 is having value 7. So, when we compare these two elements with each other, we find that array of 0 is greater than array of 1. So, we will have to perform a swap operation, and the resultant array will be 7, 15, 4, 11 and 2. This process will be followed until we have moved up to the last position or array of n minus 1 element. So, once again we will choose next two elements, which are 15 and 4 with having index array of 1 and array of 2. So, once again when we will compare those two elements with each other, we will find that array of 15, array of first is greater than array of second element. So, once again we will have to perform a swap operation. Okay. So, when we will perform again a swap operation, my resultant array will be what? It will be 7, 4, 15, 11 and 2. Okay. So, by repeating the same procedure continuously up to n minus 1 time, we will find that my resultant array will be, once again when we will compare, it will be 7, 4, 11, 15 and 2, and once again when we will compare 15 and 2, so the resultant array will be 7, 4, 11, 2 and 15. So, this whole process of comparing the elements with each other from 0th position to n minus 1 will be considered as pass 1, and the resultant of pass 1 will be that the largest element of the array have moved to its proper position, and that is the bottom one or the last position of the array. Okay. Once again we will follow the same set of operations for the other elements of the array, and let us see what will be the result. Okay. So, once again we will start the procedure from a of 0 to array of 1. So, we will again compare 7 and 4, and we will find that 7 is greater than 4. So, 4 will move up and 7 will move down, and my resultant array will be 4, 7, 11, 2 and 15. Okay. Then we will choose next two elements of the array, where next two elements are 7 and 11. So, 4, 7 is already smaller than 11. So, there will be no swapping required. So, we will choose 11 and 2. So, 11 will move down and 2 will move up, and the next or new array will be 4, 7, 2 and 11, and this process will be considered as pass 2, and we find that in pass 2 the second largest element has acquired its proper position, that is the second last position of the array. So, we find that our two elements have moved to its proper position. Here I would like to emphasize on the fact that whenever we will repeat this process again and again, like pass 1, pass 2, so all those elements which are already sorted will not be considered in the comparison process for the next pass. Okay. So, let us have the next pass in the same way. Okay. So, we will choose again the top two elements, which is 4 and 7. So, the resultant array will be, as we see 4 is already smaller than 7. So, no swapping is required, then we will choose 7 and 2. So, 2 will move up and 7 will move down, then 11 and 15. So, this will be my pass 3, where we have seen that third largest element has moved to its proper position. So, by continuing the same process, the resultant array will be 2, 4, 7, 11 and 15. So, as you can see that all the elements of the given array has moved to its proper position. Now, as we have discussed, at least one element required pass 1 to move it to its proper position. So, when we talk about the complexity of my bubble sort, so we can calculate it by using the number of comparisons. So, in pass 1 we had n minus 1 comparisons if the size of my array is n. In pass 2 we had n minus 2 comparisons, in pass 3 we had n minus 3 comparisons, and so on. So, we will have a series like this, and when we will try to summarize this series or generate the summation, so it will be n into n minus 1 by 2, and after expanding it we will find it is n square minus n upon 2, where the largest term of n is n square. So, we can say that the time complexity of bubble sort is order of n square, where n is the number of elements of the array. I hope you got this concept, and we can easily apply this up to a fixed number of less number of elements. So, same like this, in the next class we will talk about the selection sort and insertion sort. Thank you.